G'day YouTube, warbles on a lot here. On the one hand, we have this World War II vintage airport firefighter, as they were called back in the day, but these days they're known as a Water-Canon. 130 litres I've measured to the fill line about there. So there's about 30 litres of airspace up in the top there. You're supposed to only fill it to 100 pounds per square inch, which it actually is, even though the dial on it's reading 120 psi because the spring in that gauge is 40, 60, 70 years old, who knows. So we don't rely on that gauge, we rely on another gauge. I like to keep this thing, in the light of experience, at 120 psi, give it 20% more pressure, because like a fool, when I was buying this hose 3 years ago, I went into the shop and I said, my Water-Canon has a spigot on it that's 20 mil. Can I buy a 20 mil hose? And the lady at the irrigation warehouse said, no, I got a 19 mil hose, take that, it's a fire reel hose. So that's what I got. A year later, talking to the lady's hub sand, he heard I had a 19 mil hose and he said, no mate, 19 mils is not actually a fire hose. I mean, they sell it as that, but it's got too much internal resistance. And he was right and I was wrong, and I found out that when this thing had 100 psi in it last time I used it to control the grass fire around the base of what was 20 square metres of stick pile that went up 5 metres high in the sky and put out a 23 metre high flame that burnt the top off that tree in a slight wind gust, worked that one out to be, I think it was 440,000 horsepower of radiant heat, or maybe it was only 140,000. It was a hell of a lot of hotness. Whereas, you call it 140,000, down there, not last night but the night before over the Blady grass, I had 17,000 horsepower of radiant heat marching along in a line that took half an hour to burn 500 square metres. Anyway, when I was putting out the grass there with this, the second half of the 80 litres or so that I used out of the 130 available, it was pretty pathetic. So therefore I've been slightly overpressuring it, figuring that 20% overpressure probably won't hurt. Because I like solar panels, it had been my conceit to pressurise this Water-Canon using solar electricity and this little pump. Not a cheap pump, not the biggest 12 volt pump, but one with a particularly good build quality. And I got to admit, the first time, a year or so ago, I repressurized the Water-Canon using this pump. I might have done it once or twice. I took it up to first 100 and then to 120 psi, and it worked. And from memory, I think I went in 10-minute duty cycles. Having the day before yesterday, using the car engine to keep the car battery charged, brought it up to 78 psi in 10-minute cycles. I came up here and gave it a nearly 10 amp solar panel, 170 watts. And these same two long-suffering batteries that when I took delivery of them, they had resting voltage of 6.03 and 6.05 volts, so they took 57 days or something to get here. So the theory was to use that little pump sucking on the batteries, and it sucked on them at about 10 amps according to the clamp meter. And then, having sucked the batteries down from 12.85 to about 12.35, I would disconnect the solar panel at 9.4 amps or so, sometimes 9.8 amps, and give it a bit of a run. And foolishly, Muggins here let it run for 15 minutes and it came up to from 78 psi to about 102 psi. Might have been 98. And I went off for 15-20 minutes, let it cool down. Then I hit it again and the unit was still kind of warm to the touch. And I did see it rise up to 110 psi and then it dropped back down to 100 and just sat there waffling. Having had previous examples of 4 generations of these things, I took this cover off the top expecting to find an air intake that I could apply oil to lubricate the what I expected to be a smooth piston and a smooth cylinder. No such luck, it's only an output side, so it apparently gets its air in some fashion as a bypass coming up from the crankcase, which is not perfectly sealed, but it's screwed on. So I pulled the end off it and I found that there was very dirty oil, dirty grease. There were bits of grit and graphite-y looking stuff in there. And I've since learned that these things apparently use a fancy high-tech composite piston ring, and maybe they've got a particular profile on the piston ring gap so that when the piston ring is going up, it allows air, when the piston ring's coming down, it allows air to blow past it from the crankcase around the piston ring, which must deform in something like that way. And then when the piston comes back up, the piston ring gets trapped against a flat ledge and it seals against the bore and it compresses and then it flexes, so you've got something like a washer. How they get it in the groove, I don't know. How long it's supposed to last, I don't know. I'm assuming the graphite is compounded into the fiberglass Teflon polyethylene mixture so that it's a self-lubricating, flexing washer that acts as a valve. But anyway, I over-temped it and it shit itself. I will pull the cylinder off and see if maybe I can stick an O-ring in there and get it to work well enough to operate to blow up car tyres to 30 psi. But as far as the Water-Canon going up to 120, nah. Dead, done, bar, gone. It can join my pile of dead air compressors. So I wandered into town and I went to the Auto Pro shop and I bought the largest, fanciest, most expensive of the 12-volt air compressors that he had in the shop. High volume single cylinder motor, flows up to 95 litres per minute with no load. 6 metres of coiled air hose, 150 psi tyre gauge, 2.5 metre power cord, 12 volt copper wound permanent magnet DC motor, 0.5 of a horsepower, comes with sports adapters. Will inflate a 205/65 R15 car tyre in under 1 minute and 55 second, ideal for most household vehicles, motorcycles, caravans, trailers, bicycles, wheelbarrows, sports equipment and airbeds for camping with a 1-year limited warranty. Well, that's what I paid $159.99 for. And we shall see what we shall see. It does come with a very fancy twin zip, twin compartment, quick release buckled bag with quite an exotic series of special features, including a 30 amp fuse, because under full load this thing's supposed to pull 28 amp, which will be quite a shock to the 225 amp hour battery, but I can supplement that with a 10 amp solar panel. Maximum airflow, no load, less than or equal to 95 litres a minute. Airflow 10 to 29 psi, 45 litres a minute. Airflow at 30 psi, 30 litres a minute. 12 volts, half a horsepower, maximum amp draw no load 20 amps or less, maximum amp draw under load 28 amp, maximum working pressure 150 psi, cylinder diameter single cylinder 40 millimeters, ambient maximum ambient temperature plus 60, minimum ambient temperature minus 20, max duty cycle 20 minuets, air pump construction, aluminium alloy, piston ring, PTFE, Teflon, fiberglass, polyamide, graphite. So, in light of the experience yesterday, blowing up what was probably an $80 air pump, I think the $160 air pump is only going to run for 10 minutes at a stretch, half the recommended maximum duty cycle. They suggest 20 minutes maximum followed by 40 minutes cooling down, so we'll go 10 minutes followed by 20. Okay. See, told you it was neatsy, clean and cute. And all of those interesting figures are actually printed on the label, including the critical bit about the maximum duty cycle. Connectoroo. Connectoroo. Okay. Everything's kind of set up. One of the other things that it said twice in the instructions, turn the compressor on before connecting to the tyre to reduce stress on the motor. For every 20 minutes of operation, allow to cool for 40 minutes before reusing. To prevent damage to the air hose fitting, remove the inflator from the tyre before disconnecting the hose from the compressor. Okay. Gotta say, very fancy fittings for a made in China unit. Let's hope that they all hold air. Okay. Well, that looks like the orientation and the arrangement which we'll have to do. The moment of the truth. It works, Kimosabi. As advertised, sucking 19.3 amps and 12.51 putting 10 amps back in, 18.06. Okay, let's see how we go. Alright, it's reading 92. Yeah, definitely going up. Sitting there wobbling. Let's say it's been running for a minute. Pulling 24.5 amps, 12.23 volts. Yeah. So it's actually, because we're putting nearly 10 amps in, it's really only pulling 14 amps out of the batteries. Approaching 98. And yeah, cylinder's hot, motor's quite cool. 102 psi. At 3 minutes. So there you go. And now you know the actual solar powered water cannon. 105 psi. And what are we looking at? 4.5, 5 minutes. .75 amps going in, 12.29, 21.3 volts, no, 21.3 amps, call it 28 to 21 amps. I reckon that might be a sign that she's over of the heating. Okay, we've come up to 110 psi. I'm going to give it a bit of a rest, even though it's only done 6 minutes. 20.24, 12.31 plus 10. Maybe a minute later, 12.75. Still 9.7 amps. Going back in. Put that thing in the shade. Just a little bit to help it cool down, but we've got some wind. 6 minutes after a 6-minute run. 13.5 volts. Might even go so far as to say that 7 minutes on, 15 minutes off. That gives it twice as much cooling time as it gets pumping time, and it means that you suck power for 20 to 30 amps for 7 minutes, and then during that 7 minutes you're pumping it in at 10 amps, so you're really only pulling maybe 10 amps out of the batteries, and you got 15 minutes to make up the difference to the batteries. This could be quite a good workout for two sick, tired old batteries, which I would dearly love to be able to thermally shock the lead sulfate plaques from the front of the plates. And ideally, perhaps I suppose, in an ideal universe, the commutator of the electric motor is going to put a pulsating load on the battery, commensurate with the number of segments in the alternator and the RPM, so it might even be a little bit like one of those pulsating charge units, in that this is a pulsating discharge unit. Suck it out in a throbbing sine curve while pumping it in a straight flat line. What you wind up with is an input curve that mirrors the output demand for current. Coming up to 9 minutes. By which time the cylinder and the motor are at approximately equal temperature. Neither one uncomfortable to the touch. That's why I'm going to give it another 5 minutes. Oh, look at that. It had already had enough of the solar power. So 10 minutes on, solar power compensates for 6 minutes of the suction. Okay, once bitten, twice shy. Having blown that thing up by overheating it, this one can expect something closer to kid glove treatment. Okay, that's 15 minutes of cooling. Battery voltage is down to 13.46. Switchy back on. 13.23. 18.4. 18 amps. That's 9.6, comes at 13.08, 17.5. Okay, so 110 psi. We're looking for 120. It's running. .9, 20.5, 9.6 amps going in. So we're sucking about 11 amps out of the batteries. .116 psi. It is in fact going up. Slowly. But it is going up. That's 3.5 minutes to get 6 psi. Which isn't bad from 110 to 116 when you think you've got a 30 litre airspace there. Just passing through 8 atmospheres, 118 psi. There we go, the magic 120. Motor's hot, cylinder's a bloody sight hotter. .47 plus 9.6 amps minus 19.05, 19.1. I think we're in the territory where the warmer it becomes, the less friction there is on the piston ring. The warmer it becomes, the hotter it becomes, the hotter it becomes, the more pressure there is, and now we're on 122 psi. So I'll switcheroo that off. 12.6, 9.6. Okay, so yeah, that was exactly 5 minutes. There's a very slight leak somewhere up there. But we are reading 122 psi. Let's hope the pause button mishap didn't go for too long. There we go, job done. Or it will be once the little protective cap goes onto the valve. And now all I have to do is finish recharging the battery and pack it away and take it all back down to the hut. And then the Water-Canon stands fully charged, ready to anchor that there wheel track and keep the fire from spreading to there when I lay a wet line on it and light off there and do another 500 square metres in that direction. And I'll just continue my way up to the airfield at least, and perhaps to the fence. And then once I've got a bit of a catching black spot here, then I can start working at the top of the hill there and burning back down onto this in segments. Nice safe little segments that I can control. That's the theory anyway. 3.5 minutes charge, 9.6 amps going in, 13.33 volts. It's not actually a bad setup, but I do think it might be a nice idea to get those two batteries, a solar battery charge controller, that solar panel, and put them on a little dedicated lightweight trailer. So I can just grab it and wheel it to wherever I've got a need for some solar electricity to run a pump, or perhaps with an inverter mounted on the trailer. Then I can also use it to charge up batteries for a certain electric push bike. The charger of which has a similar power drain to this. I think it might suck 18 or 20 amps at the start of the charge and then work its way down to 10 amps for most of the charge and then taper off back down to 2 amps. Whereas this thing, yeah, it'll suck 20 to 30 amps and the solar panel will put out 10. The batteries are rated at 225 amp hours, so they can sustain 20 amps discharge without doing too much damage to the plates. And as you can see, 6 or 7 minutes worth of solar charging, and they've pretty much had enough. Right, so now I get to pack it all up. And before I put it back in the bag, must not forget to show you these little baubles. A football inflating needle, or a water rocket launching needle. I think that's for an air bed, and that's to adapt for bicycles that have different size valves. Happy to see it does go back into its original shape and fits in the bag again. And according to the manufacturer's blurb, if you run that thing for 20 minutes, it'll get so hot that it'll melt the bag if you try to put it straight back in there. So I think my theory of maximum 10 minutes rather than 20 minutes, and ideally 5 to 7 minute bursts, that's probably a good idea. This thing is, it's overbuilt, so overpowered and underbuilt, and I really hate the idea of using a flexible piston ring as an inlet valve as well as a compression ring in order to sustain 8 or 10 atmospheres worth of pressure. But that's what the bloke who designed it and the fella who told him to design it and the bloke who built it had in mind. So yeah, the most expensive one in the shop, and I'm going to treat it as if it's really, really fragile rather than as if it's bulletproof, because I thought the last one was bulletproof. Yeah, because it was, I don't know, $70 or $90. I got it as a gift actually. And you can buy the cheap versions for about 20 bucks. So I thought 4 times the price of the cheapest would be a pretty good one. Yep. This is the most expensive one in the shop. And it did the job, and it didn't seem to be complaining. And the solar system seemed to work pretty well as also. Okay, while the water is hotting for coffee, I will clean the wick and flame holder. Get it all shite and briny with no carbon. And fill it up from its dedicated container with my fuel funnel, as per the approved manner. Filled to 30 millimeters below the cap, which gives us our 4.5 litres. 5, 4, 3, 2, 1 is halfway between there, and the fluid level is about there. So yeah, 4.5 litres. And that's how you know at a glance that she's fully fueled, ready to go. Whereas this machine, it's going to need about 150 mils. maybe 120. Didn't use that much at all last night. Too busy trying to get it to burn rather than stop it from burn. And part of the trip to town these days is filling up with Driptorch fuel. We've already got petrol, just in case the wind dies down and we can get another burn in tonight. But I don't know whether that's going to happen. I might get to have Friday night off. And Glen Innes is not even in lockdown. Who knows? I might even socialise instead. Time to make that coffee.
And in a slow, anti-war movement to speak of and to turn up opposition to the war on terror as such, after Abu Ghraib, in spite of and allow us to be less visible but more humane, and the religion of ethics report. Thank you, Andrew. And that's the program. You can follow us at the ABC Internet or wherever you get your podcast.
There we go. Never a dull moment in the hillbilly's day. There's always something. To be done. And right now, what there is to be done is I get to sit down and have a rest and drink the coffee before it goes cold. Warbles on a lot to YouTube. Now you know what goes on between hazard reduction burns. Ciao.